Bismillah ar-Rahman ar-Rahim. Now we did, that was the last one we did. So let me continue doing these problems for Math 102. Yeah, for this section about the series, where I have the geometric, telescopic, or I have the intern for divergence. We have these three things. Or the main definition of Sn. Yeah, if I have the sequence of partial sum, then the limit will give me the sum of the series. Okay, this one, very clear. I have two things. I have this one is geometric, and this one is telescopic. So I need to do two series. Summation n equal 1 to infinity, 2 over e to the power n. Another series, 1 over 2n, n plus. I need to do two problems. This one, very clear telescopic. So let me do it, call it 1, call this 2. Then I add them here. So one, it will be what? For 1, I have at n equal 1, a will be at n equal 1, it will be 2 over a, and r is what? Well, let me make it in a good shape. I can take 2 outside. It will be 1 over e all to the power n. Now it's very clear to me. Summation n equal 1 to infinity. This is 2 over e to the power n. I can write it n equal 1 to infinity, 2, 1 over e to the power n. If you want to make it in the same format, which I know, that will be 2, 1 over e, 1 over e to the power n minus 1. So this is my a, and this is my r. Very clear, absolute value of r is so converges. So it will be s, the sum for this one, for 1. It will be a, 2 over e, over 1 minus r, which is 1 over e. That will be what? 2 over e over 1 minus e. That will be 2 over e minus 1 over e. 2 over e. So this is cancelled. So I have 2 over e minus 1. That will be that for 1. Now we'll go back for 2. For the second one, I have summation n equal 1 to infinity. 1 over 2n, n plus 1. Now I rewrite it with partial fraction over n minus or plus n plus 1. A and B. Let me see what will be A and B. Yeah, Kabar method, n equal 0. I have A equal half. Yeah, A will be half at n equal 0. And at n equal B, at n equal minus 1, I'm getting what? Minus half. So actually I can take half outside. I have summation n equal 1 to infinity. 1 over n minus 1 over n plus 1. Yeah, and this will be microscopic. This is just a number. I can multiply by it at the end. So I'll work out this one. So I have Sn equal A1 plus A2 plus A3 plus An. And that will be what? For 1, it's 1 minus half. For 2, it's half minus 1 over 3. Very clear. 1 over n minus 1 over n plus 1. So my Sn is what? This is cancelled. I have 1 minus 1 over n plus 1. Okay. So I have what? I have what will be S? Will be the limit of Sn as n goes to infinity, which is what? This is goes to 0, 1 over infinity. That will be 0. That will be 1. So this one will be what? Half times 1, which is half. So I have, this is 2 over e minus 1 plus half. Let me do the calculation. That will be 2e minus 1. Okay. If I divide, I have 2. That will be 4. This one I have e minus 1. So getting what? E minus 3 over 2e minus 2, which is this one. No, it will be e plus 3, sorry. Yeah, 4 minus 1 is plus 3. That will be 3 plus e over 2e minus 2. Yeah, this 4 minus 1, huh? Plus e. Okay, this one, what to do? Yeah, if we think of it, ln 1 plus 1 over n, I need to manipulate it a little bit. That will be ln n plus 1 over n, which is ln n plus 1 minus ln n. Now it's very clear, it's stereoscopic now. So I will, Sn will be A1. This is An, huh? A1 plus A2 plus An. With A1, it will be what? Ln, at A equal 1, ln 2, huh? Minus ln 1. Okay. Plus, at n equal 3, that will be ln 3. Minus ln 2. Okay. Plus ln 4 minus ln 3 plus blah, 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 plus ln n plus 1 minus ln n. Yeah, this is 0. Huh? I'm canceling this with this. Huh? So this will be cancelled with this. This will be cancelled with this. So this one will be cancelled by this one. Huh? The second one, I'm cancelling the second one with the, or you can write it minus. So that will make it, quick for you. What will be Sn? It will be ln n plus 1 minus ln 1, which is 0. So that will be ln n plus 1. So what is S? What is the limit? S, which is the limit as n goes to infinity of Sn. That will be what? Ln infinity, which is infinity. So this sequence, this series, I mean, this series diverges. Be careful here with the calculation. This is, I'm canceling, this one will be cancelled, the second one. Or you can write it minus ln n minus ln n plus 1. That you will not, so I have cancelled the second one with the first one. Easier it will be. But it's okay. I think both are okay. 2 over x to the power n. So I have r to the power n. I know that r to the power, he's taking when it's converge, for which x? He's putting x here. So I know that if I have the series r to the power n, what will happen? If you remember, I think we did that series, huh? When we talk about the geometric, so just to remind you, when I did the geometric ones, the geometric series, what is it? This is the geometric series. I know that if absolute value of r less than 1, then it's converged and it's a over 1 minus r, where a is the first term and r is the ratio. Let me try to deal with this. He's asking me when this will converge. Huh? He's asking me when this will converge. So what I will do, very clear to me. At n equals 0, I have a equal 1, and r is 2 over x. And r is the ratio, which is 2 over x. Okay. So what you will do, I want to check when first. I want to check when it will converge. It means I need absolute value of r less than 1. That means I have convergent, where I need to solve this inequality, 2 over x less than 1. So it means 2 over x is between -1 and 1. how to solve such problem. You need to be careful. Yeah. Yeah, actually from here, assuming x is not equal to 0, huh? I have a problem at 0. So x not equal to 0. If I multiply by absolute value of x, which is always positive, I'm getting what? 2 is less than absolute value of x. So I have x, so I have absolute value of x greater than 2. So I have x, this is an equality I know how to do, x less than -2 or x greater than 2. So this is the convergent, the values, where x, if x is between less than -2 and x greater than 2. So I need this. This is for sure correct. This is not correct. Yeah. So actually, this is the only one. Now, what is the sum? S will be what? A over 1 minus R. And that will be 1 over 1 minus R, which is 2 over x. Oops. Now, let me do the calculation. That will be what? 1 over x minus 2 over x. This will be x over x minus 2, which is this one. So, and this is the sum. So, this is the answer. Okay. And the nth partial sum of this series. He wants the Sn, huh? He wants Sn. And this is n goes to 1, so everything is okay. So I have A1 plus, because if not, on Sn, you need to manipulate it a little bit. But since it's starting from 1, so I have Sn. Yeah, but first, let me rewrite it as partial fraction. Huh? That will be what? Over n, A over n, plus B over n plus 2. Okay, as a partial fraction. So what will be A? I cover the n, put 0, I'm getting 2. Here I cover n plus 2, put -2, I'm getting -2. Actually, you can check 2n plus 4 minus 2n, so it's 4. So it's okay. Now, that will be summation n equal 1 to infinity, 2 over n minus 2 over n plus 2. You know what? I can take the 2 outside. I can take the 2 outside. I think it's better to start with 1 over n. Okay. Yeah, don't forget the 2 outside. So I have 2 plus this summation. So I'll work out this one. 1 to infinity, 1 over n minus 1 over n plus 2. Yeah. You want Sn. So it will be Sn. It will be A1 plus A2 plus An until n. So A1 will be what? 1 minus 1 over n plus 2. What's this? 1 over 3. Be careful now. For A2, I need actually A3. Yeah, let me do it this way. A3 plus A4 plus also A minus 2. I need 2 terms. Okay. Just to show you what will happen. This is 1 minus 1 over 3. At 2, I have half minus, I need the half, minus 1 over 4. So no cancellation, but the cancellation will come at the third one. I have 1 over 3 minus 1 over 5 plus 1 over 4 minus 1 over 6. Yeah. Plus blah, 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 plus this is 1 over n minus 2 minus 1 over n plus 1 over n minus 1 minus 1 over n plus 1. Yeah, let me give a bit more space. Better. Let's start from here. Plus what? At 4, 1 over 4 minus 1 over 6. Yeah, but I put 3 terms here so that we can see it easily. That will be 1 over n minus 2, minus 1 over n minus 1, okay, plus at n minus 1, that will be 1 over n minus 1. Sorry, this is n minus 2, that will be 1 over n, 1 over n minus 1 put n minus 1, I have minus 1 over n plus 1, plus the last one, which is 1 over n minus 1 over n plus 2. Yeah, my point is that we have two terms. The remaining will be two terms from the start and from the end. This will cancel with this. This not is cancel with this. This one will cancel with someone here. This one will cancel someone here, and so on. Also, if you go backward, if you go then Sn will be 1 plus half, which is 3 over 2. Okay, the numbers. Since he wanted also with the n, so be careful now. This one, yeah. This one canceled with this. And this one for sure canceled with someone here, yeah, this one will be cancelled. Also, this one will be cancelled. So I have the last two terms. I need the first two and the last two. That will be minus 1 over n plus 1 minus 1 over n plus 2. These will be the remaining ones. So I have what? 3 over 2 minus, you know what, let me do the calculation. That will be 3 over 2. This will be what? N plus 1 times n plus 2. The sum, the sum of this, that will be n plus 2. I took minus a common factor, so everything is plus. N plus 2 plus n plus 1. Okay? That give me what? That give me 3 over 2. It's a matter of calculation now. Minus 2n plus 3. Yeah, 2n plus 3 over n plus 1 times n plus 2. And that give me what? Yeah. Yeah, let's be careful the calculation. That will give me 3. I have n square plus 3n plus 2 times 3 minus 4n minus 6 over 2 n plus 1 times n plus 2. Oops. And that equals, yeah, I don't have space here. That gives me 3n squared plus 9n plus 6 minus 4n minus 6 over this. That give me what? This cancelled. So I have 3n squared plus 5n. I can take n common factor. I have 3n plus 5 over 2n plus 1 times n plus 2. Don't forget, I have a 2 here. So I have 2. This summation is this. N 3n plus 5. Do it the way you like. It's just a matter of calculation. And that will give me n 3n plus 5 over n plus 1 n plus 2, which is this one. So that will be my S. Okay, 2 will be cancelled. Let me do this one. Okay, this one is very clear. I have the sum, two different series. This is geometric, and this one telescopic. Now I need to do the calculation. So what I have here, call it 1, call this 2. I'll find them, then I add them. For the first one, for 1, I have what? A will be 3 over 4 to the power 0 at n equals 0. That will be 1. And R is 3 over 4. Very clear. So it will be S. This is absolute value of R less than 1, so converge. So it will be S A over 1 minus R. And that will be 1 over 1 minus 3 over 4. That give me what? 1 over 4, which is 4. For 2, I have what? I need this summation n equal 0 to infinity, 1 over n plus 1 times n plus 2. Yeah, I will deal with sk. Huh? This, oh, yeah, let me just rewrite it with the partial fraction, which is an easy thing. That'll give me what? A over n plus 1 minus b over n plus 2. Okay. That will give me what? Cover this, put minus 1, that give me 1. Cover this, put minus 2, that give me minus 1. This is plus. Yeah. So I have summation n equals 0 to infinity, 1 over n plus 1 minus 1 over n plus 2. So let me say sk or s, starting from 0. Actually, I don't need this. I can cancel it. That's okay. We can do this. Actually, I mean, the most important is just the cancellation. So at A0, I have 1 minus half plus at A1, it will be half minus 1 over 3 plus 1 over 3 minus 1 over 4. What I mean, if I need Sn, you need to be careful. This, yeah, Sn should be A1 up till An. But since I need the sum, there will be cancellation, so that will not make a big difference. Okay, so this will be this plus 1 over 4 minus 1 over 5 plus the 1 at the end. Yeah, well, it's very clear. This will be cancelled. This one will be cancelled. This cancelled. This cancelled. This cancelled. So I'm having 1. Yeah, I need k. Yeah, I will easily make it k or n. 1 minus 1 over k plus 2. So it will be s, will be the limit of sk as k goes to infinity, which is 1. So that will be 4 minus 1, which is 3. So that will be my answer. Okay. This one, summation n equals 0 to infinity, 0.3 to the power n. This is, you can rewrite it. Or no need to rewrite it. Very clear, I have, this is geometric. Geometric, very clear is geometric. So I have A at n equals 0, that will be 1. And R is 0.3. Notice absolute value are less than 1. So it will be S, will be A over 1 minus R. And that will be 1 over 1 minus 3 over 10. It will be 1 over, this is 10 over 10 minus 3, 7 over 10. And that will be 10 over 7. That's it. That will be the answer. Very quick one. This one, I need to be careful a little bit. I need first to factor this. So I have 1 over, this is 3n, 3k, he's putting it k, 3k times 3k. And the answer to be 3k in the middle. So I have plus 2 and minus 1. Am I right? Yeah. 6k minus 3k, that will be plus 3k minus 2. Great. That, now I need to make it as partial fraction. So I have a over 3k plus 2 minus b over 3k minus 1. Okay. I cover this. I substitute what? Minus 2 over 3. Okay. So just minus 2 over 3, I have minus 3, so that will be minus 1 over 3. Okay. Now, if I cover this, I substitute 1 over 3, that will be 1 over 3. That will be plus. That will be 1 over 3. So let me write it in the other way. That will be k equal 1 to infinity. 1 over 3 over 3k minus 1 minus 1 over 3 over 3k plus 2. To see it. Now, I can take 1 over 3 outside. And I have the summation k equal 1 to infinity. 1 over 3k minus 1 minus 1 over 3k plus 2. And they will work out these things. And then multiply by 1 over. Okay, so for this one, I have SK, SN on SK, make it SN, A1 plus A2. I'm starting from 1, so no need to be bothered. Okay, so it will be A1. A1, it will be 1 over 2. 1 over 3 times 1. Yeah, 1 over 2 minus 1 over what? 5 plus. Now at A2, I have 1 over 5 minus 1 over 8. Yeah, let me to be sure at k equal 3 or n equal 3, who cares? 1 over 8 minus 1 over 11 plus. So very clear, this will be cancelled. So I need only the first term and the last term. This is plus 1 over 3n minus 1 minus 3n plus 2. So this is also will be cancelled somehow. So my Sn will be half minus 1 over 3n plus 2. So it will be S, will be the limit of Sn, which is, this is 1 over infinity 0, so I have half. Okay, so my answer is 1 over 3 times half, which is 1 over 6. So that will be my answer. Okay, let me do next one. I think we did a good number, but let me continue. Still. Okay, that will be what? That I can rewrite it in equal 1 to infinity. Yeah, I have 3 to the power n times 3 to the power minus 1. Let me do it in steps. 2 to the power 2n times 2 to the power 1. These are numbers, huh? So I can work them out. It will be 1 over 6. Huh? So I have summation. Let me be careful. I take 3 out. Down, I mean. That will be 6 here. 2 times 3. And I have 3 to the power. So I have 1 over 6 times 3 to the power n over 4 to the power n. Yeah. This is starting from 1. So this one will be summation n equal 1 to infinity. 1 over 6. 3 over 4 to the power n. To make it in the format, or you can do the first one, or do it in the formats, okay? 1 over 6, 3 over 4, 3 over 4 to the power n minus 1. So it's in the format where I have, this is A, and this is my R. I know absolute value of R is than 1, so converges. What will be F? This is A, this is 1, this is 2. So it's 1 over 8 over 1 minus, oops, 3 over 4. 3 over 4. So it's 1 over 8. Will be 1 over 8 over 1 minus 3 over 4. That will be 1 over 4. So 1 over 8 times 4, which is half. And that will be the answer. Sn is the sequence of partial sum of the series. You want Sn. You want only Sn. He doesn't want me to do to find the limit. Just finding Sn. Okay. How to do that? Yeah. I need this sum. I need to rewrite it starting from 1, so everything is okay. That'll give me A n plus 1 plus B over n plus 2. What will be A? Cover this. Minus 1. I put minus 1. You get what? If you put minus 1, you get 1. So that will be 1. If I cover this, I put minus 2, that give me minus 1. So actually this is summation n equal 1 to infinity over n plus 1 minus 1 over n plus 2. Okay, so it will be my Sn. It will be A1 plus A2 plus A3 plus An. That will be A1 will be what? 1 over 2 minus 1 over 3. A2, 1 over 3 minus 1 over 4 plus 1 over 4 minus 1 over 5. So very clear, I need only the first term and the last term. That will be 1 over n plus 1 minus 1 over n plus 2. So it will be Sn half minus 1 over n plus 2, because this will be cancelled somehow. So this is my answer. The sum of this series, how to do that? Yeah, if you notice, this one, I can rewrite it as ln n plus 1 over this minus ln n over this. This is cancelled and this is cancelled. So actually having what? Summation n equal 2 to infinity 1 over ln n minus 1 over ln n plus 1. Yeah, I need to deal with this. And this will be telescopic. Yeah, so I do SK. I'm doing AK. Since I'm starting with A2, I should start from A1. Huh? I need A1 actually, but A1 it will make a problem. So I have A2 plus A3 plus AK or plus AK plus 1. I don't care about that. I'm doing it this way because they'll do the limit at the end. Huh? Okay, that will be what? 1 over ln 2 minus, yeah, minus 1 over ln 3 plus 1 over ln 3 minus 1 over ln 4. Very clear, I cancel the first one. Huh? So I need only the first and the last. 1 over ln n minus 1 over ln n plus 1. So this is cancelled also. Or you do the next one. It will be the same, huh? Since you need SK or... So that will be what? 1 over ln 2 minus 1 over ln k plus 1. So what will be S? Will be the limit as k goes to infinity of SK, and that will be 1 over ln 2. That will be ln infinity, which is infinity. 1 over infinity is 0. So that will be my answer. As I said, so I'm concerning about the series. I don't care. I mean, this is, you can write it in any way. Just I need the sum of k. Okay. Yeah, this one. Yeah, be careful. Yeah, this is will be what? I need to rewrite this one. That will be what? Summation n equals 0 to infinity. Okay. Minus 1 to the power n. This is 2 times 2 to the power n over 2 over e to the power 3n. Yeah, this one will be what? Summation n equals 0 to infinity. 2 is just a number, put it here. Minus 1 to the power n, and this is what? Square root 2 to the power n over e cubed to the power n. So that give me summation n equals 0 to infinity 2 of what? Minus square root of 2 over e cubed all to the power n. Yeah. So this is now my r. So my a, the first term, at n equals 0, I have 1 times 2. That will be 2. My r is this number. Very clear, absolute value far less than 1. This will be something 2 to the power 2.7 to the power 3. For sure, it's greater than square root of 2. So what will happen here? What will be S? It will be A over 1 minus R. Now be careful with the calculation. That will be 2 over 1 minus minus plus the square root of 2 over e cubed. That will be 2 over e cubed plus the square root of 2 over e cubed. This will go as a numerator, so it will be 2 e cubed over e cubed plus the square root of 2. And that will be the sum. So it's converged, and this is the sum. Sine inverse of this. You want us to do the calculation with this one? Yeah. I need Sn, which is A1 plus A2 plus A. That give me what? A1, it will be sine inverse of half minus sine inverse of what? At 1, it will be 2 over 3. Okay. Plus sine inverse at 2, it will be 2 over 3. Minus sine inverse at 3, at 2, I mean, 3 over 4. Plus sine inverse at 3 now, just to be sure, 3 over 4. Minus sine inverse at 3, 4 over 5. So it's very clear, telescoping, and this is cancelled with this is cancelled with this, and that will cancel with the with the next step. So I need only the first term. That will be sine inverse n over n plus 1 minus sine inverse n plus 1 over n plus 2. And this will be cancelled somehow. So Sn will be what? So I'm starting with 1, so I can write it Sn. It will be sine inverse of half minus sine inverse of this, n plus 1 over n plus 2. Okay. What will be my S? S will be the limit as n goes to infinity of Sn. What is sine inverse of half? We know it. Sine inverse of half. Did I do a mistake? No. Over 2. Yeah. Sine inverse of half will be what? When sine will be half, that will be pi over 6. Okay. Minus the limit of this of sine inverse n plus 1 over n plus 2. This is just a number, huh? So I just put it, the limit we can distribute. Now I can take the limit inside. That will be pi over 6 minus sine inverse of this limit. Yeah, be careful with the calculation. That will be 1. Sine inverse of 1 is what? Pi over 2. So this is give me what? Pi over 2 is what? It's 3 pi over 6. That will be minus 2 pi over 6, which is minus pi over 3. And that will be my answer. Yeah. This one, we'll do the series 1 to infinity. Okay. That will be minus 1 to the power n minus 1. Or I can write it, yeah, it will be 4 to the power n minus 1. Huh? I make everything in terms of n minus 1 over 3. What do you have here? I can make it 3, 2 times 3 to the power n minus 1. Huh? When I add them, I get n plus 1. Yeah, that will be n equal 1 to infinity, 1 over 9. Then I have what? Minus 4 over 3, all to the power n minus 1. So it's ready with the term, with the formula. So I have this is A, and this is R. Yeah, but notice absolute value of R will be greater than 1. So diverge. Okay. This one, 3 over 4n plus 1 over 3. Okay, I can make it 2 series. This is 3, 1 over 4 to the power n, and the other one, 1 over 3 to the power n. Yeah. So I can make this 1, and this is 2. How to do 1 for 1? I have A equal, n equal 0, I have A equal 3, and R equal 1 over 4, which is converge. Huh? So it will be S, A over 1 minus R, that will be 3 over 1 minus 1 over 4, which is 3 over 3 over 4, that will be 4. Okay, for 2, what you will have? Yeah, for 2, A will be, yeah, first term, A will be 1, and R equal 1 over 3, also converge. Huh? This converges, and this is converges. So it will be S, A over 1 minus R, that will be 1 over 1 minus 1 over 3, that will be 1 over 2 over 3, which is 3 over 2. So it will be the sum here, 4 plus 3 over 2, 8 over 2 plus 3 over 2, 11 over 2. And that will be the answer. Okay. 2n plus 1 over n squared times n plus 1 all square. Interesting. Yeah. What will happen here? Here is the trick. Just notice 2n plus 1. It's n plus 1 square minus n square. Yeah, I can check. This is what? N square plus 2n plus 1 minus n square. So this is the same. So I will write this series, or this, the n term, as n plus 1 square minus n square over n square times n plus 1 square. And that will give me summation n equal 1 to infinity. Now 1 over n square minus 1 over n plus 1 square. Yeah. Now if you open it up, that will be what? Summation. No, I need the Sn. Huh? The Sn telescoping. This is telescoping, very clear. Huh? Let me see it. Sn is A1 plus A2 plus An. A1 will be what? 1 over 1 minus 1 over 2 square. I leave it like this, 2 square. With 2, it will be 1 over 2 square. So this is cancelled. Huh? 1 over 3 square. Keep it 3 square. Plus 1 over 3 square minus 1 over 4 square. So very clear, I need the first term and the last term only. 1 over n square minus 1 over n plus 1 all square. So this is cancelled, 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 cancelled. This one also cancelled. So Sn will be 1 minus this. So it will be S, will be the limit of Sn as n goes to infinity, which clearly is 1. So this will be my answer. Okay. This one, I need to rewrite the series. Be careful with the calculation. N equal 1 to infinity minus 1 to the power n plus 1. A was minus 2 to the power n. I make everything in terms of n. I think it will be easier for me. 2 to the power n times 2 to the power minus 2. You know what? I can write this one as minus 1 to the power n times minus 1. Okay. That give me what? I make this minus 1 to the power n times minus 1. A to the power minus 2 to the power n. Yeah, I make everything now in terms of n. So I have summation n equal 1 to infinity. Now this one will go up as minus 4, as 4 times minus, that will be the number, minus 4. Then I combine everything in terms of to the power n. So it's minus, here's minus 2 over 2 to the power n. And this one I can rewrite it, minus 4. This one will be what? Minus 1 over 2e squared. I think better to have it this way. If you want to do it in the format, that give me minus 4 times or what will be the first term? Yeah, I can do it quickly. What will be the first term? A1. Or if you want to put it in the formula, yeah, I can make it in the formula. Yeah. Summation, since it's from 1, so I can easily make it in the formula. This is minus 4. I need the first term times minus 1 over 2a squared to the power n minus 1. So this is my A. Huh? This is my A. And this is R. Minus 1 over 2a squared. Well, very clear, absolute value of R is less than 1. So it will be S. A, what is A? Is 4 over 2e squared over 1 minus minus plus 1 over 2e squared. So that gives me 4 over 2e squared over 2a squared plus 1 over 2e squared. This is cancelled. So you have 4 over 2a squared plus 1, which is this one. This is correct. Okay. This one. Yeah. What will happen to this one? Very clear telescopic. Huh? So I have Sn, A1 plus A2 plus An. That give me what? 1 over 3 minus 1 over 1. Yeah, be careful, because I think I need two terms, huh? Yeah, that give me A2 is 1 over 4 minus 1 over 2. No cancellation, huh? But now the cancellation will come. 1 over 5 minus 1 over 3. Yeah. Yeah, plus. Yeah, I think it's better to make it the other way, huh? To make it with the minus sign. Yeah, I can make the series, huh? I can take minus summation in equal 1 to infinity, 1 over n minus 1 over n plus 2. So I'm working out this series. I'm working out this series. I need to do the SN for this because the cancellation will be very clear. I don't want to do confusion in the cancellation. So SN will be what? 1 minus 1 over 3 plus 1 over 2 minus 1 over 4 plus 1 over 3 minus 1 over 5. Now, very clear, this will be cancelled with this. Also, the other one, there is a cancellation, but it will make a confusion a little bit. Plus 1 over 4 minus 1 over 6, huh? Plus, yeah, I need only two terms, huh? Two terms from the beginning, because this is will be cancelled, and that one will be cancelled, and so on. This will be cancelled, this one will be cancelled, and so on. So, what you will do, I need only the last two terms. It will be 1 over n minus 1, huh? Minus 1 over n plus 3, n plus 1, sorry, plus 1 over n minus 1 over n plus 2. These will be cancelled somehow, huh? These will be cancelled somehow. So what will be Sn? It will be 1 plus half, sorry, minus 1 over n plus 1, minus 1 over n plus 2. So it will be S, the limit of Sn as n goes to infinity, and that will be, this is 0, that will be 3 over 2. So this one is minus 3 over 2, and that will be the answer. I need the minus 2. As I said, you can do it the other way, but you will not see the cancellation easily. Okay. This one, that will be what? Summation n equals 0 to infinity, 5 minus 1 over 4 to the power n. That's it. So A will be the first term, minus 1 to the power 0, 1, so that will be 5, and R is minus 1 over 4. I know absolute value of R less than 1, so convergent, what will be S? 5 over 1 minus, that will be plus 1 over 4. That will be 5 over 5 over 4, which is 5 times 4 over 5. That will be 4, and that will be the answer. The easy one. Yeah. This one, how to do? How to do this one? I think we did something similar. I need to factor this first. That will be summation n equal 1 to infinity. I'm going towards the telescoping, huh? 6 over, this is what, 3n? This is 3n. Okay. Yeah, what will happen? I need minus 2. I need that will be minus 2, and that will be plus 1. Yeah. Correct? Yeah. 3n minus 6n, that will be minus 3n. So it's good. Now I will do it partial fraction. That will be a over 3n plus 1 plus b over 3n minus 2. I'll do the cover 3n plus 1. I substitute minus 1 over 3. You get what? We put minus 1 over 3, that will be minus 3, that will be minus 2. Now I cover this, put 2 over 3 here. I have 6 over 3, which is 2. So I can take, yeah, that I can take common factor 2, huh? Or, yeah, and I will rewrite it, summation in equal 1 to infinity of what? Make it 1 over 3n minus 2 minus 1 over 3n plus 1. Yeah, I think this will be better. Okay. So now I work out this one. So my Sn, A1 plus A2, plus an, huh? I have what? 1 over 1 at n equal 1 minus 1 over 4 plus at 2, I have 1 over 4 minus 1 over at 2, 7 plus at 3, it will be 1 over 7. So very clear, I have cancellation at 3, 1 over 10. I have cancellation. So I have only the first term and the last term. This is what I need. Plus 1 over 3n minus 2 minus 1 over 3n plus 1. So that will be what? 1 minus this. So it will be s, will be the limit of Sn as n goes to infinity. And that will be 1. But I want 2 times this. 2 times 1, which is 2. So this will be my answer, which is 2. Yeah. Let me do 3, 4 problems, then I will stop. Sn equal this. He gave me the sequence of partial sum. This is the sequence of partial sum. Okay. And they know if the sequence of partial sum, I need to find the limit of Sn as n goes to infinity. If it's equal to a value, if the limit exists, then we say the series converge. Okay. That's what we have. So let me find this limit first. Then I will see how to find the good answer, the right answer. Sine 1 over n. Okay, how to find this limit? Yeah, this limit I need to manipulate it a little bit. That will be sine 1 over n. Or you know what? I will let t. I let t to be equal 1 over n. So I have limit t goes to 0. If n goes to infinity, then t goes to 0. This is 1 over t, sine t, which I know it. This is 1. So the limit exists. That means the sequence converge. Or the series, I mean the series convergent. This is wrong. Its sum is 0. No, its sum is 1. This is wrong. The limit of Sn equals 0. No, the limit of Sn becomes it's what? This is the limit of Sn. As n goes to infinity, it becomes 1, not 0. The limit of An does not exist. Yeah, the limit of An will be 0 because we know, as we have the opposite of the n term for convergence. Just to remind you about the theorems. When we dealt with the n-term properties, we have 2 theorems. We say if the series convergent, then what will happen? The limit of An is equal to 0. Now this is what I have. The series converge. In this case, our series converge. So without, that's it. This is what I need. Then the limit of An, it cannot be, does not exist. It will exist and it will be equal to 0. So from this, I know that the limit of An as n goes to infinity is 0. So this is my answer. This is wrong. He said the limit does not exist. No, the limit exists and it's equal to 0. He gave me Sn. This is Sn. A1 plus A2 plus, this is Sn. So it will be the series, the sum of the series will be the limit of Sn as n goes to infinity. And this is very clear. That will be pi minus 0, which is pi. That's it. The sum of the series, yeah, I think is easy to do. That will be in 0 to infinity. Yeah, minus 1 to the power n, 3 to the power n times 3 over 5 to the power n. This is, I can write it. N equals 0 to infinity. 3 times minus 3 over 5 to the power n. So A at n equals 0, that will be 3. And R is minus 3 over 5. Notice absolute value of R less than 1. So it will be S 3 over 1 minus 3 over 5. That will be 3 over 1 plus 3 over 5. That will be 3 over 8 over 5, which is 15 over 8. And that will be the answer. Yeah. Let me do this one quickly. That will be what? Summation n equal 1 to infinity. E to the power n plus 1 over e to the power 2n plus 1 minus e to the power n over e to the power 2n plus 1. Yeah, I'm thinking of it as sum of two geometric series. Okay, that will be e to the power of what? I have n plus 1 minus 2n minus 1. I have what? N plus 1 minus 2n minus 1. Let me put in the steps. Minus the other series, huh? Is e to the power n minus 2n minus 1. Okay. That will be summation n equal 1 to infinity. We have what here? This is cancelled. E to the power minus n. Okay. In the other one, I have summation e to the power minus n minus 1. I think you can work it as telescopic, but let me do it as geometric. That will be summation n equal 1 to infinity. 1 over e to the power n. And this one, summation n equal 1 to infinity. I have what? 1 over e times 1 over e to the power n. Yeah, if you want to do it in the format, or you can do a, huh? A, we call this one, we call this 2. So for 1, what is a? At n equal 1 over e, and r is 1 over e. Very clear, so r less than 1. So it will be s. I have 1 over e over 1 minus 1 over e. That give me what? 1 over e over a minus 1 over a, and that give me 1 over a minus 1. That will be for 1. Okay, for 2. So I have here 1 over a minus 1. Minus, huh? It's a minus sign. Yeah, there is a minus sign here. Okay. Now let me do the other one. That will be what? For 2, I have a at n equal 1. It will be 1 over a squared. That will be a. And the r is the same. 1 over a. Absolute value of less than 1, so it's converge. S will be 1 over a squared over 1 minus 1 over a. Okay, that will be what? 1 over a squared over a minus 1 over a. That 1 over a squared times a over a minus 1. This is cancelled. I have 1 over e times e minus 1. So this is minus 1 over e times e minus 1. Common denominator, which is e times e minus 1. Divide, I have e minus 1. So this is cancelled. So I have 1 over e. And that will be the answer. Yeah. Let me do these two, then we'll stop. I have Sn. So what will be the limit? It will be the series, the sum of the series will be the limit of Sn as n goes to infinity. So let me do this. Limit of Sn as n goes to infinity. It will be limit as n goes to infinity of ln to n squared minus 1 over n squared plus 1. I can take the limit inside since the ln is continuous function and the limit exists to n squared minus 1 over n squared plus 1. That give me ln. This is what? 2. Same degree, so it will be ln 2. So this one give me ln 2. That's it, and that will be the answer. Let me do this one. I have what? Yeah, I need to manipulate it a little bit. N equals 0 to infinity. 5 to the power n. 3 times 3 to the power minus n over 4 to the power n. So that will be 5 to the power n. Let me do the summation. N equals 0 to infinity. 3 times what? I have 5 to the power n over 3 to the power n times 4 to the power n. In other words, this is will be 3 times 5 over 12 all to the power n. Perfect. Now I have a at n equal 0. I have 3. And r is 5 over 12. absolute variables are less than 1. So it will be S A over 1 minus 5 over 12, which is what? 3 over 12 minus 7 over 12. And that give me 12 go up 36 over 7. And that will be my answer. Oh, no, sorry. That will be my answer, which is this one, which is this one. Okay. So let me stop the recording. I think we did a good number of questions. Yeah. Actually, thank you.